and welcome back to the channel. In this video, I'm going to be covering weak supervision in Python using the library Skweak, which is meant to wrap around the natural language processing library called spaCy. For those of you who don't know, weak supervision is an approach in machine learning where we leverage a set of heuristics or rules to label data for us. This means that we can easily cultivate a training set to train a machine learning model. Weak supervision is particularly used when we don't necessarily have the time or the resources to label a lot of data that can train a good machine learning model to do various tasks. In this video, we're going to be covering the Skweak library, which specifically is geared towards two tasks: named entity recognition and text classification. Now imagine this scenario. You need to have a NER model, or named entity recognition model, up and running within a few days or maybe a few weeks. In order to do that, you need to have domain experts or experts in a field go through and label a large set of documents so that you can train a named entity recognition model from the ground up. You might even be needing to just simply fine-tune a BERT model. Regardless of how you want to do this, you need to have training data to do that. Now in this approach, since you don't have the time, the resources, or access maybe to a domain expert, you still need to get the job done. What do? Well, one of the things that you can do is you can leverage weak supervision. In weak supervision, we cultivate labeling functions or heuristics or rules that take in a large collection of documents and automatically annotate them for us. If we're doing named entity recognition, this means assigning person to people found in the text, org to organizations, etc. on down the list. If we're doing something like text classification, this will mean coming up with rules for words found or phrases found within a text to give it a corresponding label. Now there are simple approaches to doing these tasks, such as gazetteers or lists, which simply go through and identify maybe a list of people and find those in a text and label them as person. There are more complex rules we can write, such as using regex or regular expressions. We can also come up with a set of parts of speech rules, leveraging part of speech tags from the spaCy library. Really, the sky is the limit here. The majority of your time in weak supervision is going to be spent cultivating these sets of labeling functions. Once that's done, comes time to cultivate a training set. In weak supervision, we use these rules to automatically cultivate our training data for us. Now in this scenario, we've got one major problem. We don't know the degree to which our labeling functions are going to really kind of correctly label our data. More importantly, we don't know the degree to which they're going to miss correct entity tags and just skip them entirely. Because we don't know anything about our training data until we actually run it through a model and start testing it and looking at the results of the model, we need a way to actually ensure that the labels that we assign are statistically viable. In Skweak and in other approaches, we do an aggregate step. In the Skweak library, we're going to be using what's known as the HMM, or the Hidden Markov Model. This is a statistical model that will take in all of your training data and isolate the outliers or problematic labels and correctly find labels that maybe have overlapping entity types and correctly assign the right one. Now it's beyond the scope of this video to cover that, but if you're interested, do take a look at the paper which came out, I think, about a year ago. Once that's done, then comes the fun part of actually training a model. Because we've done step 2, we know that the training data that we are going to give the model still won't be perfect, but it will be better than just using heuristics alone to cultivate training data. Now, I think the best way to really understand this entire process is for us just to kind of jump in and use a real-world example to try to create some rules to label some texts for us so that we can cultivate a training data set, aggregate that data set, and then start training a custom model that we can then use in production. Now, it's important to note that this is not a one-time solution. You have to test this out multiple times. You're going to have to fine-tune your heuristics or your labeling functions. Nevertheless, the Skweak library allows for you to do all this in just a few lines of code in Python. More importantly, because it wraps around spaCy, it means that you can have a very good pipeline for processing texts up and running realistically in just a few days. When it comes to labeling data, this reduces our time by maybe weeks or months, if it's at all possible at all. So let's go ahead and jump over into our Jupyter Lab notebook and start kind of taking a look at this from the ground up. Now that we're in the Jupyter Lab, let's go ahead and take a look at some of the things that we're going to be covering throughout the rest of this video. What you're going to see here is a recreation of a couple different examples available to us from the Skweak repository. If you go into the Skweak repository and you click on examples, you'll notice that you have a couple different options to choose from. We're going to be looking closely at this quick start Jupyter file, notebook file, and we're going to be following it with some modifications. These modifications are going to be coming from the NRE subfolder with the step-by-step NER. If you want to look at how to use Skweak more elaborately, let me know in the comments down below, and I'll make a much longer video that'll go through in detail all the different aspects of Skweak and how to leverage it. As you can see, there's a couple different ways that we can label our data, and that's one of the real powers of Skweak, is that step one, which is the labeling of your data. We can use the model annotator, the gazetteer annotator, the function annotator, the token constraint annotator, the span constraint annotator, and the snips annotator. And there's actually a few more that you can choose from that work out of the box with the Skweak library. We're only going to be covering a couple of these in this video. And for this video, we're going to work with the data that Skweak provides us. In this case, we need to import a library called tarfile. So let's go ahead and import tarfile right now. We're going to import spaCy as well, which is going to be how we kind of structure our natural language processing pipeline, which again, Skweak wraps around. We're going to import RE, regex. We're going to also be importing a couple other things. Specifically, we're going to be working with the Skweak library. And now that we've got everything kind of imported, everything should work fine. If you don't have Skweak installed yet, it installs like any other library. If you go to the Skweak repository, you'll notice that you can run a simple pip function to actually install everything that you want to use. So pip install Skweak, and you should have Skweak installed. And this should work on Windows, Mac, and Linux without any issue. So let's go ahead and just copy and paste some of the data that we need from the repository available to us. And I'm going to go ahead and comment that out. And what this is allowing for us to do is to go ahead and use the data that is available. If you look in our data subfolder, you'll notice that we have this couple different things here, but you notice that we have Reuters small tar GZ. And this is coming from the Skweak repository. It's the Reuters data set, which is oftentimes used for different things like named entity recognition and text classification, specifically for topic modeling. In this video, however, we're going to be using it for named entity recognition. And let's take a look at this data to see what it looks like. So I'm going to print off texts 0, and you'll notice that it's a simple Reuters news article in which we have discussions about things like businesses. We've got some money referenced with dollar signs, and we've got a couple other things that might be useful for a named entity recognition model to be able to find and extract, such as company, money, etc. on down the list. What we're going to be working with in this video are a couple different approaches for automatically annotating this data set. Now, the very first thing that we can do is we can use the model annotator. So let's go ahead and do that right now. In order to start creating our custom spaCy pipeline with Skweak, let's go ahead and first import the spaCy small model. So we're going to say NLP is equal to spaCy.load, and I'm going to scroll down and zoom in just a little bit for you. And we're going to be loading in the NCore Web SM, so the small English model. And we're going to be disabling specifically the NER component, so the named entity recognition component, and the limitizer. These won't be necessary right now because we're going to create our own NER pipeline. Once we have that made, let's go ahead and create our first doc object, and this is going to be equal to NLP, and we're going to just work with texts 0. So there's one that deals with Best Buy. Once we have that created, we can go ahead and start working on our model annotator and see what this might look like. So let's say I wanted to use a model annotator. What does a model annotator do? Well, the model annotator lets us use a pre-trained spaCy model to go ahead and auto-label data for us. So it's going to label things that it's already seen before. This is sometimes a useful approach if you don't have a baseline model started, but it shouldn't be used by itself. Instead, you should always use a model annotator with other data as well, because the whole point of creating a Skweak unsupervised or supervised weak supervision approach is by using domain-specific information. All a model annotator will let you do is poorly annotate data that's already been worked into a model. So there really isn't a point in just using the model annotator by itself. It's usually used in tandem with other things. But let's go ahead and do it. So we're going to create an object called Annotator. And what this annotator variable is going to point to is specifically squeak.spacy.model annotator. Pay particular attention to the capital M and the capital A here. Now this is going to take two arguments. The first thing is going to be what we're going to call this model annotator. I'm going to call this spaCy underscore MD, and that's a reference to the media model. The next thing that we need to point to is the model itself. Now this can be any model that you want. It can be one that you've pre-trained for another custom workflow, but for right now I'm going to work with the standard and core web MD model. And that's going to point to the spaCy media model. So that's what's going to be used to automatically annotate this text for us. Now remember, in this example, we've disabled the NER component. That's going to be important in just a second. So let's go ahead and create a new doc object, and this is going to be the annotator, which is going to run over this earlier doc object here. The nice thing about Skweak also is that it still lets you visualize data because it wraps around spaCy's visualizing displayer automatically. And so we're going to use squeak.utils.display underscore entities, and this is going to take two arguments here. The first thing is going to be the object that we want to annotate, and the next thing is going to be the component that we want to use to do the annotation. In this case, the spaCy MD model. And if we execute this, we'll notice that we have an annotated text already available to us, and we can see it displayed. What do we notice? Well, we've got certain things automatically annotated. So for example, we've got Atlanta incorrectly listed as an organization, Reuters listed as an org, Apple Inc. listed as an org. We have number 3 for Cardinal. That's fantastic. And we've got, I want you to pay particular attention here, 199 listed for money. And so we're seeing money listed on down below. We're seeing quantity listed correctly, etc. What if, however, I wanted to do something a bit more robust and work with data that I already have to better classify certain organizations? Now, I noticed that Best Buy Co. right here, clearly an organization, a company, is misidentified because it is not listed. So it's a missed true positive. What we can do is we can use Skweak to improve this annotation by working with some of the other type of functioning labels that are pre-built for us, or annotators that are pre-built for us. So let's take a look at a couple of those to try to improve our result a bit more. Now that I've looked at this information, and I know that there's certain patterns about companies, I know that if a proper noun is preceded by a co or something like this, that it's likely going to be a company. So I can use that basic rule or that basic knowledge about companies to create a custom function that will label annotations for us. So we're going to do this with the Skweak library using the function underscore annotator. And what I'm going to do right now is I'm going to copy and paste over a handy dandy little function that they've already written for us. Let's break down what's actually happening here. So here we're creating the function name. In this case, it's called company underscore detector underscore fun. Great name. It's going to take in a doc object, and it's going to iterate over each chunk in noun chunks. For those of you who don't know, noun chunks are things in the spaCy spans that are self-contained. They can be bigrams or trigrams, etc. They're going to be things that are linked together in some way. So a token essentially that has multiple tokens that have a collective identity. And you often see this with multi-word tokens for things like Best Buy, Scott Moore, etc. on down the list. The next thing that this is checking for is if, when this is all stripped out, if the lowered form has Corp, Inc., Ltd, LLC, SA, or AG in it. And if it does, then we're going to go ahead and label that chunk as company. Now this is really handy because to do this effectively as a custom labeler and a custom rules pipeline in spaCy, you have to use a custom component in some cases. So the function annotator is really useful not just for weak supervision, but also for helping you create more elaborate, really kind of robust pipelines in spaCy pretty effectively in only a few lines of code, without having to do a lot of hard coding of custom components. Let's go ahead and take a look at how this might work in practice. Now that we've got our function made, we can call something like company underscore detector. That's going to be equal to squeak.heuristics.function annotator. And this is going to allow us to put in essentially two arguments. The first thing is going to be what we want to call it. In this case, we're going to call it company detector. And then we're going to run the next argument, which is going to be the function that links to. In this case, the function is company underscore detector underscore fun. And now that we've got that annotated for us, let's go ahead and run a doc, create a new doc object, which is going to be equal to the company detector, and we're going to run that over the previous doc object, and then we're going to say squeak.utils.display underscore entities, and we're going to pass in that doc object again, and we're going to run over our company detector. And it looks like I've misspelled utils here. There we go. That should work now. Company detector cannot be found, and that's because I misspelt it over here. A couple typos, and now we see that we have a new set of annotations. So one of the things that we're noticing right out of the gate is that AT&T is correctly being labeled as a company here. Walmart Stores Inc. is correctly being labeled as a company here, but we're noticing Best Buy Co. is not correctly being listed. Why might that be? Well, if you look in our list up here, we don't have Co listed. So one of the things that we can do is we can improve this result by adding in Co after everything. And then we notice that we actually do have it working now. So what we're able to do there is identify take in a set of heuristics, look at the results, and come up with a better way to improve them. And now we've got that working just fine. We notice that we do have one problem, and that's retailer Best Buy is being listed as the entire company. I'm going to go ahead and simply be okay with that right now, because one of the things that I can do to improve these results further is I can use a gazetteer, or a list of known companies, to basically create another type of heuristic annotator. So let's take a look now at the gazetteer annotator. This is going to work by taking in a list of different kinds of entities that correspond to specific labels. In our case, we're going to be working with lists of companies. So let's go ahead and make an object called tries, and this is going to be equal to squeak.gazetteers, always misspell this word, .extract _JSON _data. Now this is going to expect a JSON file, and in our case in this repository, we're getting this from the Skweak repository, which is going to be the Crunchbase company's JSON file. This is a nice data set of around 55,000 different company names. And so what we can do here is we can go into that specific repository or specific subdirectory data and grab crunchbase companies.json. And then what we can do is we can load in that gazetteer into our Skweak pipeline. So we can say gazetteer is equal to Skweak gazetteers. There we go. Gazetteer here. You need to have a capital G, very important. Gazetteer annotator with a capital A. And we're going to call in this gazetteer object. And so we're going to have to give it a name. In this case, we're going to give it the name of gazetteer. Keep it very simple. Again, we're following the documentation here. And we're going to pass in the second object being, or second argument, which is going to be this variable here, which is going to correspond to this list. Again, think of this as a fairly simple way of constructing a fairly robust entity ruler that you would normally do with your typical spaCy pipeline. So if we execute that, and we get one error, no such object in that Crunchbase companies.json. It's a compressed, so .gz. Now it should work just fine. And as we can see, we're loading up around, and this, oh sorry, I said 50,000, 539,000 different company names. And we know that this is going to all correspond to specific entities that have the label of company. So let's go ahead and now see what that looks like by visualizing it. So we can say doc is equal to gazetteer. We're going to call this variable here, which is going to be our entire annotator pipe. And we're going to pass in that same doc object. Now again, we're going to say squeak.utils.display _entities. And we're going to pass in doc again, and we're going to specifically visualize the gazetteer pipeline. So we're going to say gazetteer, there we go, and we're going to execute that. And now what you're able to see is a list of companies being all labeled for us. As we can see, it doesn't follow the rules that we set above where Best Buy Co. is being labeled. Instead, we're seeing this passed over right now, and that's okay because we're only visualizing this pipe. So when we pull all this together, we'll see that Best Buy Co. in fact retains that company label. But for right now, with our simple list, we're able to see all of these things annotated, and we see Best Buy down here being annotated because our earlier pipes have not labeled it as a company correctly in these examples. So what we're able to see now is our essentially our entity ruler, Gazetteer, functioning as an effective way of labeling data. But as we can tell, it needs the other preceding labels, which come from our model annotator and our function annotator to catch things like AT&T Inc. and Best Buy Co. Now the big question is okay, if we bring all these together, are we going to have an effective pipeline if we can use them all in tandem? And the answer is, yeah, you'll have an effective pipeline, but these are going to be hard labels. What we want to see now is how the Skweak library really can function for us in our workflow by using weak supervision, and also by aggregating all of these labels and identifying, and creating a key data set that has the labels accurately applied when there's might be overlapping and incorrect labels assigned. So let's go ahead and take a look at how to aggregate our data and train the model now. So the very first thing that we have to do is we have to get a new set of docs that have all of our 3 different annotation methods applied to them. Now there's a couple ways to do this with only one line of code. In this video, I'm going to be a little bit more verbose just so the code is a bit more readable for students of all different backgrounds with Python. So let's create an object called new docs, and this is just going to be an empty list. And what this list is eventually going to be is it's going to be the collection of our new documents that have all the different annotators kind of applied to them. So let's go ahead and just kind of take a look at our names as a quick refresher for what we have for each of these different annotators. So we weren't too creative with our model annotator, we just called it Annotator. So that's going to be one of the things that we need to pass over it. We also need to use company detector as a second annotator, and then finally our Gazetteer as a third annotator. So what we're going to do is we're going to iterate over each of these docs. So let's say for doc and docs, and now we're going to be able to, in this loop, grab each document. Now what we want to do is we're going to create a new document that's going to be equal to each of these things applied to it. And we're going to do this from the inside out, or maybe from the outside in. Let's go ahead and just try both. So let's say first Gazetteer. Again, I'm going to scroll up because I can never spell this word correctly. There we go. And we're going to pass that over the doc. And what we can also do is we can wrap this around another function, which is going to be our company detector. And let's again scroll up and make sure that we're spelling everything correctly. And in fact, we are calling this company detector, so that's good. And so the final thing that we need to kind of pass over everything is annotator. And what we want to do is we want to append this new document to these new docs. And again, there are better ways to do this in just one line of code, but for right now, for this video, I hope this makes a bit more sense for the audience. And we're going to append that. So what we should have for doc and texts, I'm going to scroll back up real fast, and we need to make sure that we pass this document initially through our NLP model so that we have the doc object actually created. So we're going to say for text and texts, and we're going to say doc is equal to NLP text. So that's going to create the initial annotation, which creates the doc object for each text, and we're going to append. So what we should have is, and we can check this out real fast by saying print the length of the texts, and we want to have the same length of docs here. Print the length of new docs. When we do this, it'll take just a few seconds to run. What we'll have are properly labeled all of our new documents. I'm going to pause the video here as this iterates over everything. It'll take a few seconds to do that. Now that we have all of these documents made, we see that we have the correct number of new docs and the correct number of new texts, both at 195. Now it comes time to actually create our aggregator, which is known in the Skweak library as an HMM, which stands for Hidden Markov Model. This is really the crux of the whole library, is this approach and the training of a new model. So let's go ahead and create our HMM model right now. So following the documentation, we're going to call this variable HMM, all lowercase. And we're going to make that equal to squeak.generative HMM, capital HMM here. And this is going to be called HMM all lowercase, and then the second argument that we need to pass in are the labels that we can expect this model to look at. So we wanted to be able to identify right now just company. We don't really care about any of the other labels right now, we're just focusing on company, and this is really useful for if you have overlapping spans where one organization might not necessarily be a company name, but it might be an institution like a university. I'm not going to be able to cover that in this video. If you want to know more about the power of the HMM and kind of a lot more that you can do with Skweak, let me know in the comments, because I have a feeling that this would make for a very good multi-part series on this channel. Let's go ahead and execute that cell, and we have our HMM now created in memory. At this point comes time to actually fit the HMM model, and we do this by simply saying HMM lowercase dot fit, just like you do with any other machine learning library, and we're going to fit it with our new documents, which all have corresponding labels. I'm going to execute this cell, and you're going to see it iterate over something multiple times. In our case, it iterated over it 4 times with 4 different epochs, and you can actually analyze the results right here. We're going to skip that for right now and just take a look at what this looks like by simply displaying out one object. So let's say Squeak.utils.display underscore entities, and we're going to again load up docs, new docs now, 0, and we're going to load in the HMM model to visualize what it might actually look like. And we have an error. Source HMM cannot be found. And the reason for this error is because I'm trying to use my old documents and not my new ones that have been annotated with the HMM model. So if we go down, let's make a new cell, and let's create a new doc, and we're going to call this equal to, in our case, we just want to pass the HMM model over our one of our docs. So we're going to pass it over new docs 0, and this will create a new document for us. Now what we can do is we can grab this same line that we did up above, execute it down here with new doc. So the new doc object passed over our HMM model, and we're seeing that it's able to aggregate a lot of the labels that we have been giving it with our different annotator rules. As we're able to see though, we have a couple problems. The aggregate model hasn't worked perfectly. We see retailer, Best Buy Co. Labeled collectively like we saw a problem up above. We see problems like Apple Inc. not being correctly annotated because it hasn't been applying our heuristics that we saw above. And we also noticed that one of the things that has happened that is a good thing is more is no longer being applied to be a company anymore. Nevertheless, we are seeing some of the advantages and disadvantages. Now, a lot of this will be improved if we had a larger set of training data for the HMM model to kind of work with. We only have 195 examples here. If we had, say, 10,000, the model would do a little bit better about finding these different patterns and aggregating them a bit more. Nevertheless, this is just a quick demonstration of what you can do with it, and with a little bit of work, you can get this fine-tuned to work a lot better on your own data set. But now comes really the fun part, which is training your own custom model with these new annotations. And Skweak lets us do that pretty easily in just a couple lines of code, and it's going to be using the CLI, or command line interface, in this Jupyter notebook. Now to create this new training data, we're going to again iterate over our documents. Again, there are better ways to do this. If you want to use the Skweak library as it's probably intended, I recommend using the fit and aggregate, and you can do that by calling your HMM model at this point. Again, I'm going to do it a little differently just so it's a little easier to understand what's happening. So we're going to call this HMM docs, and again, we're going to make that to an empty list. We're not going to be doing list comprehension here, and we're going to iterate over our texts once again. So we're going to say for text and texts, and we're going to create our new doc. Actually, we're going to create our doc, and I'm going to follow a lot of the things that we did up here, except I'm going to just be using the HMM model for doing all of the annotations. So unlike before, we don't have to actually do all of this. We can just say HMM, pass that over the actual text itself, and then we're going to append this HMM underscore docs with our new doc object. Actually, one other thing that we do need to do, though, is we need to make sure that we change all of these labels in each of these things to the spans that the HMM annotator finds. So at this stage, we're going to say doc.ends is going to be equal to doc.spans, and we're going to grab the spans that correspond to our HMM model. And this is going to take all the entities from the doc.ends and populate them with the span annotations from our HMM model. And then that's going to allow us to then go ahead and use these HMM docs to, And again, we had to create the doc object first by passing it over our initial model. Now that we've got all of our documents, let's again take a look at our length just to make sure it adds up to 195, and it does. And now we have all of our different model docs from our Markov model annotated with that model. What we can do now with the Skweak library is we can drop all these in to the proper spaCy training format. So let's go ahead and take a look at our repository. And I'm going to create a new folder here, and we're going to call this training data. So I'm going to call it training_data. Again, there's better ways to do this, but for demonstration purposes, this will work just fine. Next, what we want to do is we want to call the Skweak library. In the utils, we're going to grab the doc bin_writer. What this is going to do is it's going to write all of these documents that are annotated. So what we can do now is we can drop all of these different HMM annotated data into a directory, which we have here called let me go back to it, training_data. And so this is going to allow us to drop everything into the new .spaCy binary file. So let's say squeak.utils.docbin_writer. This is what it's going to allow us to do it. This is going to take two arguments, our HMM docs, so the documents that you want to drop into the file, and then the file. So for us, it's going to be training_data, and we're going to call this Reuters small.spaCy. Again, we're following the docs here in the naming convention. And when we execute this, it should take only a second, and it's going to drop all 195 into this folder right here, and we see that file right there. At this stage, we can use the command line interface to train our own custom spaCy model. And so what I'm going to do is I'm going to copy and paste from the Jupyter notebook that I provided for you, just because I don't want to write all of this out by hand, and I'm going to specify where it's located. In my case, it is located in training_data, Reuters.small, and the output that I want to drop it in is again going to be in training_data, Reuters small. And when I'm initializing this model, I'm going to update this right here, _data. And again, this is bad practice because I'm actually using the same validation data as I am for my training data. This is just for demonstration purposes. And what we're doing here is we're specifying that we're going to be using the vectors from the English medium model. We're specifying that the language is English. This is kind of populating the config for us that we're going to actually be using. And we're training specifically the NER pipeline. We're optimizing for accuracy here instead of efficiency. So we are going to be saving these vectors with our model. If we execute this cell in a Jupyter notebook, we should see it just start to run up. Now, it's not going to be populating the results here in the Jupyter notebook. If you use this in the command line, so in your terminal, you will see the whole training process occur. I'm going to pause the video right here because at this point, the training process is going to take a little bit of time, and we're not going to spend time in this video waiting for it just to finish. Instead, let this run and you'll see that you've got a new model trained specifically on these 195 label data that you were able to cultivate through weak supervision. Again, this process is not foolproof. It's not meant to be. Weak supervision is going to be an iterative process. You're going to have to fine-tune some of your functions for labeling. You're going to also have to kind of look at how the HMM or the aggregate model is actually performing as well. And it's going to be a little bit of kind of development over the course of several different tries. Again, this is only supposed to be used if really the time to cultivate a gold standard data set that is crafted by a domain expert isn't feasible in a realistic period of time, or if you want to kind of just experiment to see if a model is even a viable option for the problem that you're facing. You should not use this model as the be-all end-all for your final production at just one go. Do spend some time and do some trial and error. As always, thank you so much to all this channel's Patreon supporters. I really do try to keep all this content free for everyone. I have a bit of good news to report. I have been a little late in posting videos this month because I've just signed a book contract to make all of these kind of Jupyter books that I've been doing in a published print form with the CRC Press. And the good news is that one of the things that is in the contract is that all of the videos and the Jupyter books that are online will remain free to everyone. This will just be a print version that you can purchase to go side by side with them. It also means that a lot of the material is going to be improved upon, and a lot of this work has been thanks to all the Patreon supporters on this channel who have kind of been able to let me do all this stuff and continue putting stuff out by keeping the channel alive and supporting all the costs that go along with it, from microphones to computing resources to server space for hosting the websites and the Jupyter books. So thank you all to everyone, and I look forward to posting videos again more regularly starting next week.